Okay, so higher order differential equations means anything above second order would be called higher order differential equations. For examples, second, third, and any other higher order derivatives, if you find in the differential equation, you call them to be higher order differential equations. Here we are going to see how to find the general solution to higher order differential equations, especially with constant coefficients. There's no generalized procedure when there are variable coefficients. We put them into category like Cauchy, Euler, Legendre, etc. But with constant coefficients, there's one procedure, one standard procedure. The general solution would be given by y is equal to yc plus yp. Yc would be the complementary function and yp would be called the particular integral. Let's see complementary function. Let's see how to find the particular integral when certain functions are there. Okay, let's see first. Especially when to find yp, I'll just write first the standard format of a second order differential equation. A second order differential equation would be of this form. Y double prime plus p of x or p1 of x into y prime plus p2 of x into y is equal to q of x. Now, yc anyways is a trivial thing which we have already discussed in the previous videos. Now, if q of x is equal to e power ax format, how to find yp is what? How do I find yp is what I'm talking about in this video. Okay. Now, if q of x is equal to e power ax, just simply the theorem is like replace. There's a theorem, but I'm using here as a shortcut. Replace d by a in f of d. What exactly is f of d? Let me write here. Now, capital D is nothing but d by dx or d by dt. Okay. Now, if I'm going to pick up all the derivatives in the equation, suppose let this be 1. If I'm going to pick up all the derivatives, then I'll be having d squared y plus p1 into dy plus p2 into y is equal to q of x. It would be of this format. Now, if I take out y common, then I'll be having something like d squared plus p1 into d plus p2 whole y is equal to q of x. Now, whatever is there, it's like a polynomial or a quadratic equation in D. So, quadratic polynomial in D. So, I'll be calling this to be f of D into y is equal to q of x. Now, how do I find particular integral is? I'll first rewrite this equation as yp is equal to 1 by f of d. If f of d comes towards the right, it would be 1 by f of d into q of x. Mind you, d is an operator, so it has to be operated upon some function. D is a differential operator. Differential operator. And it has to be operated upon something. Okay. So that's why when I'm writing f of d, if it is open, it's not valid. I have q of x, so I'm operating upon q of x, the d, the polynomial in d I'm operating. Now let's see what I will do is I'll be replacing in f of d, d by a. What when I have q of x to be e power ax? Okay. Yeah. Now, what if this f of d is equal to 0? Or in other words, if f of a or d is replaced by a, if f of a is equal to 0, then what should I do? Then what should I do? That means what? A is a factor. A is a factor of the function or the equation f of d. So what should I do? I should check a is a factor how many times? That is, if a is a factor k times. Again, this is a theorem, guys. I'm just writing it as a shortcut. If a is a factor k times, then what I will do is, I will write yp as 1 by d minus a power k into q of x or e power ax, because here my q of x is e power ax. Okay, so what do I do? What I'll be doing is, I'll be writing x power k by k factorial into e power ax. This is how I will write. Okay. Yeah, I'll be writing like this, and this is the procedure. Now, Let me finish off the procedure when q of x is equal to cos x or sin x. If q of x is equal to cos ax or I mean cos bx or sin bx, what do I do? Replace d squared by minus b squared. Okay. Of course, replace d squared by minus b squared. Again, this is a theorem. I'm using this as a shortcut. What will I do? In y, when I'm finding yp, 1 by f of d is there, na? Wherever d squared terms are there, I'll be replacing. Even if it is cos bx or sin bx, anything, I'll be replacing f of d square kind if it is there, I'll be replacing by minus b square. You can ask me, what ma'am, if there are no d square terms and only d terms are there, rationalize, try to get d square and then replace again b square only. That's how I'll do when I have cos or sin x. Okay. I'll just end this video here and try to do problems in the next video on how to find yp when e power x and cos bx sin bx are there.